Hi, I'm Jim Knudson with Industrial Specialties Manufacturing, or ISM, and we are a master distributor for United Silicone. United Silicone is world known for their expertise in the manufacturing and molding of silicone. And we also have Brenda Denny with us, who is United Silicone's worldwide product manager. Hey, Brenda.
Hello, Jim. Hello, all. Welcome. Pleasure to be here today.
Good. And I forgot to mention to you that I'm the new business development director at ISM from a position standpoint, which just means I sell and love to troubleshoot in your plants. We're going to be talking about compliant seal bars and jaws. But before we get into talking a little bit more specific about the products, we do have a takeaway for you. And that is that not all compliant or silicone material, seal bars, are created equal. What that means is if you see a silicone that's red-orange in color, that doesn't mean that it has the capabilities or performance characteristics of United Silicone silicone. That doesn't mean it's good to 550 degrees F. It doesn't mean that it's thermally compliant. It doesn't mean that it's going to be made to a tolerance of plus or minus 5 thou of an inch. So just kind of put that into your hat for a moment while we now begin to go into talking a little bit more specifically about seal bars. When Brenda and I are out in your plants or fielding your phone calls, troubleshooting issues you guys have with your packaging applications, the types of pain points that we see are gummy or sticky compliant material, Teflon tape needing to be used to hold the compliant material on the seal bar, Teflon tape being put over the seal bar, the compliant seal bar, so that a product doesn't stick to it. We hear about compliant material that's not thermally conductive, meaning it's acting more like an insulator, which is really what silicone's natural state is. We also see and hear about metal on metal bars that are creating welds instead of seals. And when you look at it, it's not surprising. The sealing process is made up of time, temperature, and pressure. And if all those ingredients aren't exactly right, when you have two metal bars coming together, you're going to get a weld, especially when they have to overcompensate for one of those components. And really, bottom line, what we hear about is leakers, bubbles, and inconsistent seals. How do we get rid of those, and how do we come up with more consistent seals? And then the last point is longevity. How do we get compliant seal bars that last longer and we don't have to change out as often? And with those bullets, why don't we, Brenda, is this a good time to transition over to our short video?
Sure.
Hi, welcome back. What'd you think? If you couldn't relate directly to exactly what was going on there, my guess is because of how widely Teflon tape is used in the packaging industry, you just like duct tape is for the homeowner, you could probably relate to the time involved. So the question begs to be asked, okay, so what does United Silicone do to combat the use of Teflon tape, other than what you saw in the video? Well, here's an example of our bonded Teflon to silicone. So you have a very simplified seal bar here. And there are two components here. One is the silicone or the Teflon covering. The other one is the slight crown, if you can see that, in the seal bar itself. And the benefit to that crown is during the sealing process, it's going to slightly roll and press out any kind of air bubbles or air that's caught in the seal. And the other benefit, actually, if I back up just a little bit, in relation to United Silicone's material, the majority of the time, because of the highly engineered material itself, we find that most ingredients in most films don't stick to the silicone. So you may not need the Teflon covering, but we can always test for both and determine what is best for your individual process. Brenda, do we have questions we want to get into, or are we there a little bit quickly?
Sure, we can do that. If you can do some show and tell with one of the bonded seal bars and talk about that process, that silicone to metal bond.
Perfect. This is exactly what Brenda just mentioned. This is silicone bonded to aluminum. And this is done in our manufacturing process. And there are a couple benefits to that. Number one, if you just have a silicone seal, and this has got a mushroom mount. So even with a tight mushroom mount, you're still going to have an air gap in between the seal itself and whatever it's being held to, the metal bar. That's going to prevent heat from flowing through the seal bar. When you have a seal bar that is bonded to aluminum, your thermal conductivity is many times better. That, and we have the ability to grind the silicone in our post-process. So our flatness tolerances are considerably better. That's when we can hit up to plus or minus 5 thou of an inch and better. And this also gives us the ability to mount this to the metal seal bar in a number of ways. This gives us many more options. And this is just another example of a gasket or one of the ways we're going to mount an unbonded seal bar to a bar with a T-mount. Okay.
Perfect. On that piece that you had shown with the silicone to metal bond, that is actually also representative of a dovetail, if you will, that you could see in your show and tell. Actually, that showed up quite well on the camera. So the idea that seal bar slides in to your machine for clamping. How about lengths, Jim? What's the longest length of a seal bar that can be produced?
Actually, I haven't dealt with the longest lengths that we can mold. Do you happen to know what those are, Brenda?
I do. Again, our longest length that we can do, and can't say that we've done one yet, but it's 110 inches. And that question is very dependent on the format. And the gasket format is better when we get longer than the bonded format. And again, that goes to, Jim, what you had talked about flatness and maintaining flatness.
Okay, good. Thank you.
Other questions that often come up is about durometers.
Okay.
If you want to touch on that.
Sure. Durometer is speaking to the hardness or softness of the silicone. From an identification standpoint, we deal with the Shore A scale, and a 40 durometer is going to be our softest silicone. And stepping up in 10-point increments. Just a good example is most of us can relate to the eraser on a wooden number 2 pencil. If you're to play around with it a little bit, that is very similar to a 60 durometer rubber. So right in the middle of the scale. So the descriptions above 60 are going to be firmer, all the way up to 90. And those below 60, all the way down to 40, are going to be softer. And just to tag onto that, when we deal with thermal compliance, the firmer durometers are going to be more thermal compliant, and the lower, softer durometers are going to be a little less thermal compliant.
Perfect. And how about some of the different materials, the formulations available specifically FDA?
Okay. We do have a couple FDAs. We have really what is referred to as FDA that's available in 60 and 80 durometer. And we also have a 3A dairy certified silicone. We also have a Thermacell that has a little bit higher thermal compliance. Normally we used in more highly automated heated applications. And then we have an Ultrasil. All of these are good up to 550 degrees F and have strong thermal compliance.
Okay. I believe that takes us into our wrap up. If you want to take us from there. And
okay. Well, we appreciate you spending time with us. Thank you. Feel free to contact us via email, calling into the office, any way you want if you have a question. We look forward to the conversation. Thank you.